Moving on to this example, we want to find the equation for the tangent line to the graph y equals 1 over square root x at these three different x values. So instead of finding the slope of my tangent line at each of these points separately, I'm going to find a general equation for the slope of my tangent line and then plug in those x values. It'll be more efficient. So remember, the slope of our tangent line equals the limit as h approaches 0, excuse me, of f of x plus h minus f of x all over h. Or the slope of the tangent line equals the limit as x approaches x naught of f of x minus f of x naught all over x minus x naught. So for this problem, I'm going to use this one. You could also use this, but honestly, this is the most commonly used form for the general form of a slope of a tangent line. In the answer key to the homework, I will show both ways every single time. So if you want to see problems worked out both ways, please look at my Google Drive with my answer keys. So I'm going to stick with this one, but this also works. So it's the limit as h approaches 0 of 1 over square root x plus h minus 1 over square root x all over h. So if I plug in 0, I get an indeterminate form. So I need to simplify this rational expression. I will do common denominators on my numerators. So I'll multiply this one by square root x and this one by square root x plus h. Okay, so now I have the limit as h approaches 0 of square root x minus square root x plus h. And now in my denominator, I have h multiplied by my common denominator. So once again, if I plug in 0, I get an indeterminate form, 0 over 0. So now I will do the conjugate of my numerator plus so now my numerator becomes x minus x plus h, and my denominator is h square root x plus h multiplied by my conjugate, and this is all the limit as h approaches 0. So now I see if I distribute my negative, these x's will cancel and I'm left with the negative h on my numerator. So we have the limit as h approaches 0 of negative h over h square root x plus h multiplied by my conjugate. So now we'll see these h's cancel. Now coming up here, I have the limit as h approaches 0 of negative 1 over square root x plus h multiplied by my conjugate. So now I can do direct substitution of 0, and I get negative 1 over square root x plus square root x, because both of these h's go away to zeros. So square root x multiplied by square root x is x, and this is 2 square root x. So now I can simplify this This is x to the 1/2 power times x to the 1st power. I add my exponents. That becomes x to the 3/2 power. So that is the slope of my tangent line for any x value. So now that I have that, I can move on to the problems down here where I will find the tangent lines. And I'll do that in the next video.